Hello MIS 411 class. Welcome to Chapter 4, Video 1. So in this video, I'm going to be going over the relational data model. So as you might be aware, we're now transitioning from the analysis phase of the SDLC, where we dealt with things like the EERD, conceptual diagrams. We were working with supertypes and subtypes and attributes and cardinality constraints, etc. And now we're actually embarking on the design phase, the third phase of the SDLC, where we're going to be talking about the logical and physical data models. And as part of that, what we're going to be doing is designing a relational data model. And what that is, you will see in the coming slides. But suffice to say, what we're doing now is essentially moving from a blueprint, a concept, a planning phase, into where we're actually creating things that are now translatable directly into database technologies. So the first learning objective for this chapter is going to be a better understanding of the relational data model. So the relational data model occurs in the logical data modeling phase. As we studied in Chapter 1, this is the third phase of the SDLC. We just completed the analysis phase previously with conceptual diagrams, EERDs, and now we're embarking on the design phase. And as you might recall, there are actually two data models that occur in the design phase. It's the logical data model and the physical data model, both of which are going to be relational data models. So the logical data model is going to be the translation of the conceptual data model that we've been working on, the EERD, into a model that is now consistent with a specific database platform. And what that means is, with the EERD, we have things like supertype, subtype hierarchies, we have many-to-many relationships, and we have other items that don't actually translate directly into a database. That is to say, it's not so much that they don't translate, it's that you can't take them sort of one-to-one and move them into a database. Some of the things like entities will remain more or less unchanged, or mostly unchanged, but some of the other items that we've been working with in the EERDs don't. And so a big part of the logical data model and this phase of the SDLC is actually moving from the conceptual, the high-level conceptual understanding of the data, and not just the high level, but the detailed conceptual understanding of the data into database-specific constructs, right? And that's something important to remember. This is where we're actually creating a database, and hopefully this is something that we can look forward to, because now we're actually finally taking what was a blueprint and turning it into something that is usable from a technical perspective. So a logical data model actually does not necessarily need to be relational, okay? But typically, it will often be relational, and because we're using Oracle, which is a relational database management system, it will be relational in our case. Now, could you create a logical data model for a NoSQL database, which is not relational? Absolutely. But for us, that's not what we'll be doing. And typically, I think for most examples you find online, it will be a relational data model. And the relational data model is really going to represent data in the form of tables. And we're going to call them different things. We'll actually call them relations. But what we've been working with in our SQL exercises, where we're selecting from tables, that's essentially what we're talking about here. We're taking entities and we're turning them into tables. And then the relationships become something else. And you'll see that as we move forward. So the process of transforming the conceptual EERD to a logical data model, we'll see us migrating our entities, attributes, and relationships, and that's what we've been dealing with to this point, right, to tables, also known as relations, fields, and keys. So the relational data model, what is a relation? As defined, a relation is a named two-dimensional table of data. And I don't want to overcomplicate things. This is basically the table that we've been dealing with, in our SQL exercises. So where are we at right now before we get into relations, right? We have entities, we have attributes, we've identified the identifiers, and we may have other types. I haven't represented them here, but we have other types of attributes, multivalued, composite, etc., right? And so where are we going now? So now we're going into relations, and you might be familiar with this specific table. It's one that we've been working with in our SQL exercises. And so by two-dimensional, what does that mean? Essentially, it's two-dimensional in the sense, we have columns in one dimension, and then we have rows in another dimension, right? So that's all it's saying by two-dimensional. And this is the table of data. So this is a relation. And, like I said, we'll commonly refer to it as a table as well. So the translation between what we have and what we're going to, right, is that what we had before we would call an entity. So this would be the entity, right? And then the entity instances, as you recall, are specific examples, right? So in the entity of student, we might have a specific entity instance of John Smith, right? And so now what we have is a relation, a table. And really that's just the translation. And the other thing to understand is that there's another representation, another way to represent the relation, and it's in this format. Essentially, you can see that the relation name begins it. So this is the student table, right? Student entity. Here's the student table in SQL, right? And then here we have a simple representation. If you just need to reference, this table in a one-liner. So you have the table name, right? Open parentheses. You have all the fields in the table, and again, we'll use an underline to identify the primary key. And we'll talk more about primary keys and the identifiers later. So, EERD versus relational model. I mean, a lot of this chapter, a lot of what we're going to be going over in this video actually has to do with taking what we had before and how does it translate to what we have now with a relation, right? So in an EERD, we call them attributes, right? First name, last name, date of birth, etc., right? In the relational model, we're going to call them columns or fields, basically synonymous, right? So we have the ID column, the first name column, etc. We can also call these fields. And again, you should be familiar with this from our SQL exercises. So, right, we have EERD, we call these things attributes, right? And now what we're going to call them instead is columns or fields. So in EERD attributes, in a relational model, we call them columns or fields. So likewise, in EERD, as I mentioned, we have entity instances, right? Each of these would be an entity instance. And these are the examples you did in the phase 2 deliverable, right, where you came up with some sample data for each entity. Each one of those was an entity instance, right, John Smith, etc. And in the relational model, we'll call them rows or records. Okay. And again, so it's a change in terminology. There are also some technical changes as well, but really just understanding, where we're coming from to where we're going. So let's get into primary keys a little bit, actually. So in the entity model, or in EERDs, right, we have an entity, and we would use an underline. We would identify the identifier, and the identifier, as you recall, uniquely identifies the entity instance, right? And so a primary key definition in the relational model is an attribute or a combination of attributes that uniquely identifies each row in a relation. Okay, and so they do refer to these as attributes. Again, these could be attributes, columns, or fields. In the relational model, you'll more often than not hear them referred to as columns, right? But attributes works just as well. And so it's the same thing, right? So here we have the ID field or attribute in the relational model in the table, and it's a primary key. And again, uniquely identifies. So what can't we have? I cannot have 2 1s, right? I cannot have 2 3s, right? It has to be unique. Each entity instance has to have a unique ID. And again, as I mentioned before, so the simple format, if we need to represent this on a one-liner, you just have the table name, the relation name, use an underline to represent the primary key. So here we said that the underline represented an identifier, which was a unique attribute, and here we're saying the underline represents the primary key, unique attribute. Same thing, right? So in the EERD we call it identifier, and in a relation we'll call it a primary key. So it's one thing to look at a primary key as being sort of the academic primary key and the other notation, but let's actually look at how the primary key is represented specifically in SQL Developer, for the tables we're working on in Oracle, okay? So if you were to go to Edit Table, if you right-click on one of your tables, for instance, Student, and you go to Edit Table, and if you go to the Columns navigation item in the left, right, you see this little key icon with a star in the PK column, right? And it's right beside ID. So this is how you would represent a primary key. What you can notice is, if you select columns, you'll see a primary key up here, but you'll also, down below, if you click on the Constraints tab right here, you'll actually see that My Student PK, and this is the name of the primary key. You can name this whatever you want, right? But it is the primary key, okay? And that can be a tiny bit confusing, right? Because you might say, well, My Student PK, primary key, well, I thought ID was a primary key. My Student PK is just the name that you give it for it's like I don't want to say an alias, but essentially it's the friendly name that you give it for the primary key. But you can also see, if you click on Constraints, right? So you move from columns to constraints, and what you can actually see is that constraints primary key my student PK, the primary key constraint named my student PK, down below, right, is using the ID column. I know it's not the most intuitive thing. This is probably the most intuitive way to see a primary key. Like I said, click on columns after you're editing table and look for the little key icon. Now you can have a composite primary key, and you may remember composite identifiers from the EERDs, right? And a composite primary key or composite identifier is where you have more than one field or attribute or column, right, contributing to the primary key. So you could have, in this case, for instance, where we have student ID and major ID being both parts of the composite primary key, what you can have is multiple entity instances or rows, multiple rows with the same student ID, right? And you can have multiple rows with the same major ID, but you cannot have multiple rows with the same combination of student ID and major ID. For instance, if you had the student ID of 1 and the major ID of 1, you could not have another 1, 1, but you could have a 1, 2, or a 1, 3, or a 3, 1, right? We'll see this in practice as time goes on. And again, as before, if you would click on the constraints, so I do want you to get familiar and comfortable with using the SQL Developer tools. So you right-click on a table, you go to Edit Table, click on columns, you can see how the columns are laid out, the data types, all the metadata, right? Click on constraints, and you'll actually see the different constraints. Ignore the foreign keys for the moment, because we're actually going to come back to these in a minute, but if you can see over here on the primary key now, and again, the name is really the name of the constraint. It's just whatever you decide to name it. Student major PK is what I decided to call it, right? But down below you can see that the primary key, called student major PK, is composed of selected columns, right? Student ID and major ID, right? Available columns means that if you wanted to add more attributes to the primary key, you could, but the way it's defined right now is student ID and major ID, and so that's a composite primary key. So now we're going to talk about foreign keys, which is another type of relational key. And these are somewhat more complicated than primary keys. And a foreign key is defined as an attribute in a relation that serves as the primary key of another relation in the same database. Now I'm going to change the terminology a little bit based on what we know and what we're talking about when we refer to relations and attributes. So let's call this a column in a table that serves as the primary key of another table in the same database. Okay. In Chapter 1, we actually went over this really briefly, this idea that instead of actually having all of the attributes filled out, what we might have is a reference to a different table or reference to a different entity, right, where we would retrieve the information from the secondary entity. And so let's look at row 1 in this table major, right? I have ID 1, I have the name CS, computer science, right? And instead of saying what the college is right here, I don't say CSTEM right here. Instead, I have a reference, a lookup, right, to another table. So I say I have the number 4, and I go over to college, and I see that the number 4 is CSTEM. Likewise, for row 2, I have the ID of 5, and it's the name is MBA, and the college ID is 1, right? And so I go over to the college table, and I can see that 1 corresponds to COBA, College of Business, right? So in that way, I have a column in a table, right, the college ID column in a table that serves as the primary key of another table. So the college ID in this table, in the major table, is actually the primary key of the college table. So what I'd like to do here also is show in the simple representation that I've been including previously, the foreign key is represented as a dashed underline. Okay, so here we have the major relation or table, right? I see that ID is the primary key, it's underlined, right? Name is just a normal field. And then college ID is a foreign key, it has a dashed underline. Okay? Now, unlike the primary key, the foreign key is not represented as an attribute of the containing entity in the EERD. So remember what we might have in a major entity, for instance. We would have the identifier, right? We would have the what now has become the primary key. However, instead of actually having the foreign key, we wouldn't have college ID in here. It's actually represented by the relationship. Okay, and so that's a big difference between the primary key and the foreign key, is that in the EERD, you can basically expect to see that the primary key as an attribute, but the foreign key is actually being sort of inferred from the relationship between major and college. And obviously we'll look at the rules for how to convert from an entity into a table over the course of this chapter. So I just want to let you know that you will often end up with extra fields that you didn't see in your main EERD or your conceptual EERD that are due to the relationships between entities, and the foreign key is one of those items, right? And so in the EERD, I put not applicable because we don't really have a name for the foreign key. It really is, like I said, it's caused by the relationship between entities, okay? But in a relation, i.e. a table, we'll call it a foreign key. And as I kind of started this slide, basically the idea with a foreign key is that you have an attribute, or you have a field in one table, right, that points to another table. And something that you can see, and again, we'll be going over the rules of this, more closely over the rest of the chapter, but because of the type of relationship, right, we have college one to many, college to majors one to many, right? You can actually kind of see that play out to some extent, right? You can see that sort of fan crow's foot shape, right? Here we have the major, right? And many majors can have the same college, right? Many majors can share the same college, right? But a major cannot have two colleges, cannot be part of two colleges, right? Every major is offered by one and only one college. And so you can kind of, like I said, kind of see this diagrammatically as you convert from EERDs into relations. So as before, in the interest of kind of relating this to exactly the tools we're using, in SQL Developer, again, if you were to right-click on a table and go to Edit Table, right, when you're looking at the columns in the navigation, you'll see, for instance here, the college ID, right? Now up top, there's no field, as there was with primary key. With primary key, you see the little key icon. For foreign keys, you don't see anything actually up here. However, down below, once you highlight this, once you highlight that field, then down below on the Constraints tab, you can actually see that there's a college FK. FKs often stand for foreign keys, right? And you can see that the constraint type is a foreign key. Okay, and then if you look at the actual constraint itself, what you see is we have the constraint, right? We have the type is foreign key. We have the name, and again, the name is whatever you decide to name it. Really, it can be whatever. It doesn't really matter very much. And then down below, you can see what it's referencing. So this is the major table, right? And it's referencing the college table. And it's referencing, remember how a foreign key must reference a primary key of another table? So it's referencing the college table, the college primary key. Now, let me pause for a moment and just say that it's not always 100% that a foreign key has to refer to a primary key. We'll get into details of that, but for the sake of argument, that's what we're going to kind of go with. Okay, I think it really is more about it has to be a unique constraint, more so than a primary key. But in any event, so on constraints, you can see that there's a foreign key from the major table that references the college table. It references the college table's college primary key, right? And then over here, what are you associating? In the major table, the field is called college ID, and in the college table that you're referencing, the field is called ID, right? And so those have to be equal. And that's essentially how you would go from computer science to CSTEM, as we saw, in the previous slide, right? So recapping relational keys in a relational data model. There are really only two relational keys that we'll be dealing with: primary keys and foreign keys. So a primary key uniquely identifies a row in a table. So each row in a table in a relational data model that has a primary key, there is no other rows that would have the same primary key, right? A table can only have one primary key. It's crucial that you understand this and remember this. You cannot have a table that has multiple primary keys. There can only be one primary key per table. A primary key may consist of a single column or multiple columns, composite primary key. Now we've seen examples earlier in the slides of that, right? The primary key could just be the ID field, or it could be a combination of the major ID and the student ID or something along those lines. A table will usually have a primary key, but you can actually define a table without any primary keys at all. Okay? So critically, understand that a table can only have one primary key, and that just because there's a primary key with multiple columns, a composite primary key, doesn't mean that it has multiple primary keys. It's still a single primary key composed of multiple columns. Now, a foreign key references a single row in a different table. Okay? And it references a single row in a different table. And that's because a foreign key will reference a primary key or a unique key constraint in a different table. So as we know that a primary key or a unique key constraint will only match a single row, so when you have a reference to that in a table as a foreign key, you'll only return one row. You'll only be able to match one row. Okay? A table can have 0 foreign keys, but it could have many foreign keys. And each foreign key in a table, I mean, it could be 0, but if there's more than 0, each foreign key can be a single column, or it can also be multiple columns. And what dictates that is whatever it's referencing in the other table, right? If it's a primary key in the other table that it's referencing, it needs to match, right? So if you have a composite primary key in one table that has 2 columns in it, and you have a foreign key reference in another table to that composite primary key, then the foreign key also needs to be composed of multiple columns. So we're going to go over a lot of examples, I mean quite a few examples, both hands-on as well as sort of academic, conceptual, of primary keys and foreign keys. But an important thing that we should note at this point are some of the properties of relations, or, in other terminology, some of the properties of tables. And specifically, again, for us, we're going to be doing Oracle tables, right, in an Oracle database. So what are some table, essentially, I don't say constraints because that's such a loaded word at this point, but what are some restrictions, essentially, on tables? Okay, relation, a table, has to have a unique name. You cannot have 2 tables named the same thing. You cannot have 2 relations named the same thing in your schema, in your database for all intents and purposes. So, right, you can't have 2 product tables. Okay. Each cell value is atomic, single valued. Okay. And so what can we see here? We did have multi-valued attributes when we were working with EERDs. So we might have a major, we would have the curly bracket, right, on major, and we would say it was multi-valued. And they might be an MIS major, but they also might be majoring in Spanish, right? In a table, you cannot have a multi-valued cell. Right? Every cell has to be single valued. Every row needs to be unique. Okay? And now, in order for a row to be unique, that just means that one of the fields has to be different. Right? What you cannot have is 2 rows that are exactly the same. This is a restriction of relations. Whether it's a pure restriction on Oracle is going to be immaterial. For our purposes, this is a restriction on a relation, and this is basically a part of, I think, the definition of how relations work. So in order for you to have 2 rows, there has to be at least one difference between them in one column. So even if one of these columns was just a 4, if everything else is the same, that's fine, as long as one of these columns is just a tiny bit different. Each column has to have a unique name. Okay, so you can't have 2 major columns in the same table. Let's say for some reason you had the major column and you're like, oh, I also want to have, a foreign key to a different table. And so you try to create another major column, right? That's not allowed by the properties of relations. Now, these are less restrictions and more just things that you should be aware of. In a relation, part of the understanding of a relation or definition of a relation is that the column ordering is not significant. That is to say, you shouldn't necessarily rely on, when you define the table, having defined major before or above, depending on how you look at it, academic level. It doesn't really matter. For all intents and purposes, you should just think of the columns as essentially unordered. Now, whenever you go into SQL Developer, it'll always look like there's the same order, and when you select from it, it'll often return in the same order, but you shouldn't rely on that or consider that to be part of the fundamental characteristic of a relation of a table, if that makes sense. And likewise, row ordering is not significant. Now, of course, you can use order by, right, which we've done many times. So you can sort the rows as you retrieve them, right? And again, it's one of those things where if you do a select star from the table, you'll get the rows in the same order each time, just about. But you should not consider there to be an inherent ordering of the rows, right? You need to take responsibility. And in both of these cases, essentially, you need to take responsibility. If you want to show the columns in a certain order, then you should specify the ordering of the columns. If you want to show the rows in a certain order, then you need to do that with an order by, right? Don't rely on the table to retain the column ordering sequence or the row ordering sequence. So one topic that we'll be exploring in more detail, certainly as we get into the nitty-gritty of converting from EERDs into relational tables, into a new data model, is multivalued attributes. They seem so simple when we did them in entities. You simply surround with curly braces an attribute, and that indicates that it now has multiple values. But when we convert into table structures, into relations, into relational data model, you cannot actually have a multivalued attribute. As we saw in the previous slide, we said that a cell value must be atomic. It must only have a single value. So what we might have had before, you can see on your screen, is that we have employee ID 100, Margaret Simpson, is teaching both an SPSS course as well as a surveys course, right? However, this doesn't work. And so what we need to do is we need to transform from a single record to multiple records. So we add a single record with 2 course title values, right? And what we need to get to actually is this, where we now have separate records, 1 record for each of these values. So now you can see that each of these records, the first record only has a single course title, and the second record also only has a single course title. And we might say, hey, that's great. So that's simple enough. We just basically copied all of the values from the original record into the second record, and now it works. But here's the problem, is employee ID is still a primary key. Okay, and the employee ID now is no longer a primary key because why? We have 2 100s, and that doesn't work. So we're going to have to figure out a way to deal with that, and that's what we'll be doing later on in this chapter. But just be aware that this is one of the issues that we will have to address.